Hello and welcome to the MSUM Planetarium's virtual field trip. Today we're going to be taking a look at celestial motions in our sky. We're going to look at daily motion first. We're starting off with our sky as it is this morning. Notice where the sun is in our sky. Can you find the sun? Go ahead and point to it. You found the sun. It's over on our left. Now, I'm curious if you might be able to figure out what direction that is. Use some observations that you may have made in your life up till now. Try to figure out what direction you might be pointing to when you're pointing to the sun. Think about, what does the sun do in the morning? The sun rises. And where does it rise? Well, most of us have noticed that the sun rises in the east. So let's go ahead and take a look at our cardinal directions here. We've got the east over where the sun is. We're facing south at the moment, and west is over on our left. Now, I wonder if you've ever noticed, if you watch the sky throughout the day, does the sun always appear to be right where it is? Have you ever noticed? Most people have noticed that the sun doesn't always stay there, and typically we talk about the fact that the sun rises in the east and sets in the west. So, would you say that the sun moves across the sky? Or is it something else? Let's take a look. If I fast forward time in here, we can take a look at how the sun appears to move across the sky. There's no question that the sun doesn't stay in the same place in our sky throughout the day. But is the sun actually the one that's doing the moving? Well, you can think about it, and we typically talk about the fact that the sun is the center of our solar system. The Earth revolves around the sun. And so the sun isn't going around us. We're going around the sun. But it takes us 365 days to go around the sun. So it can't be that it's because we're going around the sun that makes it look like the sun moves across the sky, because it doesn't take 365 days for the sun to get from one spot in the sky back to that spot. So there's got to be something else going on. What do you think it might be? What other motion do we know the Earth does? Motion that only takes, say, about 24 hours? Maybe you're starting to think more about the Earth's rotation. The Earth rotating on its axis is what makes it look like the sun moves across the sky throughout the day. And since it takes only about 24 hours for the Earth to spin in place, it only takes about 24 hours for the sun to start in one spot and return to that spot. So we've got the sun appearing to move across the sky. Of course, it's our own rotation that causes that. But now we're heading towards nighttime. You can see that the sun is about to set over in the west. And we're going to take a look at how the sky changes as we transition from daytime to nighttime. So I want you to take a look and see if you notice any changes as the sun sets. What do you see? You're probably seeing a lot more stars. We had one star out during the daytime, but now there are a whole lot more stars out at night. What do you notice about these stars? Some say that the stars are twinkling, which is definitely true. What else do you notice about them? Some say that some are brighter than others. Also very true. Do you notice what they're doing? can you see that they look like they're moving as well? Let's imagine we wanted to explain this motion to someone who'd never experienced it before, someone who didn't know that the stars move across the sky. How would you say those stars are moving? We could use our cardinal directions to help us. You might notice that they look like they're rising in the east and setting in the west. That sounds awfully familiar, doesn't it? There's something else that rises in the east and sets in the west, and we were just talking about it. That's right, it's the sun. The sun rises in the east and sets in the west, and we just got done explaining how it's really not that the sun is moving, it's that the earth is rotating. So if we're noticing the same type of motion from the stars, do you think it's possible that the reason that the stars look like they're moving the same way the sun looks like it's moving is for the same reason? That rotation of the earth? Do you think that's possible? It sure makes sense, doesn't it? So we know that the stars aren't actually going around us. It just looks like they are because of the earth's rotation. So they all look like they're rising in the east and setting in the west. But now I'd like us to take a look. We're going to rotate around and we're going to face north instead. Instead of making you turn around in your spot, I'm going to turn the sky around. So we're going to face north. I'm going to bring the sky around here. It's easier for me to do it than to risk you losing your balance. So I'm going to bring the sky around and we're going to face north. And I want you to keep watching the sky and see what you notice. To help you, I'm going to make the stars a little bit brighter. See if you notice a change in our stars. I've basically taken us from a city sky in the Fargo-Moorhead area to a country sky. When you get away from the street lights and the light pollution of larger cities, you can see a lot more stars. So now if you take a look at the sky, what do you notice? Remember, we said the stars were rising in the east and setting in the west, and they're still doing that. But are all the stars doing that? Look towards the center. Do you notice one star that doesn't appear to be moving? It kind of looks like all the stars are circling around one of the stars in the middle. Any guesses as to what that star might be? If you use your cardinal directions, that can help you. Because the cardinal directions can often give you the hint that you need to figure out what that star is. And that star is the North Star. And if I asked you what was special about the North Star, what might you say? Some people guess that the North Star is special because it's very bright. It's the brightest star in our night sky. But that's not true, is it? Look around at the other stars. This is an accurate depiction of our night sky. Does the North Star look like it's the brightest star? No. It's not even the top 20 brightest stars. So it's not the brightest star. Most people know from their education that the North Star helps us find north. That's where it gets its name. But we just got done saying that all the stars look like they rise in the east and set in the west because of the Earth's rotation. So what might be special about this star? Why does this star not follow the rules? Well, the special thing about this star is it happens to be directly above our North Pole. Our North Pole points to the North Star. Let's go ahead and indicate that on our right there. That's the point in the sky that our North Pole points to. And you'll notice that that North Star doesn't stray from that crosshairs very much. So looking at the sky, the North Star doesn't appear to move. And that's because the North Pole points to it. But what difference does that make? Well, you can imagine it like being riding on a merry-go-round. Imagine that you decided to sit in the center of the merry-go-round, and you took a friend with you and your friend sat on the edge. Who do you suppose would move more, you or your friend? Well, your friend's going to make great big circles around you. Are you going to move very much? No, you're not going to move very much. You're basically going to sit there and spin in place, right? Because you're sitting on the axis of rotation. The North Pole of the Earth is the axis of the Earth's rotation. So this star is like sitting in the center of the merry-go-round, but in this case, the merry-go-round is the Earth. So that star isn't breaking any rules, it just happens to be in a special spot in the sky. So now we've learned about the mystery of the stars and how they appear to move. And that includes, of course, the sun, our daytime star, and the moon as well. All because of the Earth's rotation. Thank you for joining me.